let's talk about combining the product and quotient rules. So in this video, I'm going to do two big derivative examples where each of them requires more than just the product rule or just the quotient rule. We're going to be using multiple rules within each problem. So my first example you can see here, we definitely don't have a basic derivative rule that covers all of this together, not unless we multiply it all the way out, which we don't want to do. But for example, the x to the third power on its own would be fine, right, for a derivative. This quadratic in the parentheses, this we could differentiate on its own, and then same thing for this root function at the end. So we're going to see this as this times this times this, and we'll say, all right, I see a product, it's multiplication, so I'll use the product rule. But we have three products here, or sorry, three things being multiplied in the product. So what I'm going to do is just kind of tape two of them together temporarily. It actually doesn't matter which two you buddy up. Usually I just take the first two and buddy them up temporarily, but it really doesn't matter. I could take these two as well and it comes out the same way. All right, so this whole thing will be the f in my product rule, and then root x minus 3 will be my g. And then when it comes time to take the derivative of this part for the f prime, I'll bust out another product rule. Okay, so for this product rule, like I said, my f is x cubed times x squared plus 5x plus 1. And my g is root x minus 3. So for each of these, I'll need blue f prime and blue g prime. And then once I have them, I'll put them together in the product rule, which is f prime g plus g prime f. All right, so we need f prime. And we say, oh, well, this is something times something else. So I'm going to use the product rule for its derivative. So I'm going to switch colors, identify the product rule, and now I can separate out x cubed as one function, x squared plus 5x plus 1 as the other. Each of these I can differentiate just using the power rule. We get 3x squared for f prime, 2x plus 5 for g prime. And now I can use this information I have in the green to get me blue f prime, so the derivative of all of this. So using the green, I'll do f prime g plus g prime f. F prime g plus g prime f. All right, so now the green is done. I don't need to look at that again. I just need to complete my scratch work by getting blue g prime. And this is just a power rule, right? Because root x is the same as x to the 1/2 power, its derivative will be 1/2 x to the negative 1/2 plus 0 from the 3. Or if you want, you can write the fancy version of this, which is 1 over 2 square roots of x. All right, so now that I have all four of the pieces I needed for my product rule, I'm going to put the four blue pieces together in the product rule, so f prime g plus g prime f. So overall derivative of the original function f is f prime g plus g prime f. Okay, so f prime is the big one. I'm not going to simplify anything. F prime g plus g prime f. And that is my final answer for this derivative. All right, let's try another one. So this new function we see down here has a lot going on in it. So it has multiplication in the denominator. And then overall, we also have division where it's like some stuff up here divided by some stuff down here. So I can tell in the course of computing this derivative, I'm going to need the product rule and the quotient rule. But I want to be very careful about which one I kind of use at the start. We want to decide, like, from what this is overall, can I come up with an f and a g where this is all f times g? Or an f and a g where this is f over g? And that second option is the way I'm going to go, right? Overall, this is something divided by something. So I can make the top of it f, the bottom is g. So when I go to do my final answer, I'm going to start plugging stuff into the quotient rule formula, the low D high minus high D low thing. All right, so let's get our scratch work started. The f is 1 over x squared plus 1 over x cubed. And g is the whole denominator, like that. All right, so we need f prime and g prime for these two pieces for our formula. F, it doesn't need a product or quotient rule, but I do need to rewrite each of these rational expressions as x to a power. So by definition, 1 over x squared is the same as x to the negative half. And then 1 over x cubed is x to the negative 3. So I'm not taking a derivative yet in this step. I'm just reformatting what I have so that then it's easier for me to see using the power rule to compute each of their derivatives. Okay, so f prime is done. Now I need g prime. And then when I look over here, I say, oh, look, this is multiplication, right? So I have x to the 10th times root x minus 7x squared. So to compute this derivative, I'm going to use the product rule. So for this product rule, we'll have x to the 10 as the f, root x minus 7x squared as the g. Each of these I can differentiate with normal, like memorized power rule stuff. So I have f prime is 10x to the 9, g prime is 1/2 x to the negative 1/2 minus 14x. All right, so I'm going to use this new green information in the product rule formula to get the derivative of blue g. All right, so using the green, f prime g plus g prime f. F prime g plus g prime f. All right, and now that I have all four of my blue pieces, f, f prime, g, and g prime, I'm going to put them into the quotient rule, which I was originally trying to do. So all of this is going to go into the quotient rule, which is low d high minus high d low over the square of what's below. So I'm going to go g f prime minus f g prime over g squared. All right, this is going to be a monster, but we can do it, and then we're not going to simplify at all. All right, so my overall derivative, f prime of x, I'm going to do g times f prime, so this g times f prime minus f times g prime, so minus f times g prime, and this right here is this big derivative here. Think I can fit it. I'll do my best. All right, so all of this is a big set of parentheses here. Okay, so I have g f prime minus f g prime over g squared. So I'm going to have the original x to the 10 root x minus 7x squared. And that's my final answer.